Hi everyone, welcome to Tara Academy. Today we are going to discuss about matrix, its basics, basically its definition, and what are the different types of matrices. As you can see in the screen, what is a matrix? Matrix is nothing but a rectangular array of elements and it is represented in the form of square braces. And what is the size of a matrix? Size of a matrix is nothing but it can be represented in the form of, suppose consider A is a matrix, okay, then what is the size of a matrix? That is m by n, where m represents number of rows of a matrix and n represents number of columns in a matrix. For example, consider A is 1 2 3 4 5 6. So what is the size of a matrix? You can see number of rows are 2 and number of columns are 3, which gives you 2 by 3, which is the size of a matrix. I think it's clear. Then coming to the next one. What is a zero matrix? If all these elements of a matrix is 0, that is if these are all are 0, then it is a zero matrix. Then what is an identity matrix? Before going to an identity matrix, one thing should be clear. That is, what is a principal diagonal? Principal diagonal can be told in one condition, that is, if the matrix is a square matrix. Okay, that is the only condition for the principal diagonal elements. That is, if m and n are equal, then it is a square matrix. That can be 3 by 3 or 2 by 2 or 4 by 4, etc. So, if you come to the what are the principal diagonal elements, let me take a simple 2 by 2 matrix. Okay, consider this is a 2 by 2 matrix. The elements in this diagonal are called principal diagonal matrix. Coming to what is an identity matrix? If the principal diagonal elements are 1 and rest of all the elements are 0, then it is a identity matrix. That is, what is an identity matrix then? 1 0 0 1. Is that clear? If we wanted to do it in a 3 by 3 matrix, then simple 1 0 0 0 1 0 0 0 1. This is a 3 by 3 matrix where the principal diagonal elements are all 1. I hope that is clear. Coming to different types of matrix. Okay, what is a row matrix? What is a column matrix? That is, if we come to row matrix, if only there are rows in a matrix, that is 1 2 3, so there are no columns, then such a matrix is called a row matrix. Then what is a column matrix? Column matrix is nothing but if we have only columns but not rows. Example 1 2 3. It can be 1 2 also, or it can be 4 also. Is that clear? Okay, I hope that's clear. Coming to here, what is a symmetric matrix? If A is equal to A transpose. Here comes the question, what is an A transpose? Simple, the interchange of both rows and columns is called A transpose, a transpose of a matrix to be precisely. So let us consider a matrix. Let me take a 2 by 2 matrix first, so it will be clear. Okay, so if this is a matrix, the transpose of this matrix is 1 minus 2 3 and 5. So this is a transpose of a matrix. So here, what is a symmetric matrix means, if this transpose is equal to the original matrix, then it is a symmetric matrix. So let me explain you what is a symmetric matrix. Okay, so for symmetric matrix, if we consider a 3 by 3 matrix, let me take an example. Okay, 1 1 minus 1 1 2 0 minus 1 0 5. Let me take this as an example. Now A is equal to A transpose is a condition for a symmetric matrix. Let me make a transpose of this matrix. Okay, that is, now I am interchanging the rows with a column. So 1 1 minus 1 will be 1 1 minus 1. 1 2 0 will be 1 2 0 minus 1 0 5. Okay, precisely A is again reflected here as A transpose. This is called a symmetric matrix. Okay, skew symmetric matrix. Here, if A transpose is equal to minus A. Simple. Let me explain you with an example so it will be more clear for you. Okay. Let me take an example. 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. Now this is a matrix A. Okay. Now what I am going to do is, first of all, let me see what is minus A. Okay. What is minus A? Simple. We will be doing it 0, minus 1, 2, 1, 0, minus 3, minus 2, 3, 0. So what is A transpose? If we go to the previous slide and check 0, 1, minus 2, 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. So as you can see, it is similar to A minus A. Okay, that is A transpose is equal to minus A, which is precisely the skew symmetric matrix. I think it's clear until there. Okay, let's go to the next one. Precisely, what is an involutory matrix is nothing but A square is equal to I, that is an identity matrix. If you do the multiplication of a single matrix and if the result is an identity matrix, that is we have only principal diagonal elements as 1 and rest of the all elements as 0, then such a matrix is called an involutory matrix. Next, what is a nilpotent matrix? The similar way, if the matrix multiplication of the same one, it can be A square or A power m, and this is called the index, and at which index if the entire multiplication results you a zero matrix, that is all the elements of a matrix is a zero matrix, that is all the elements is a 0. Okay, example 2 by 2 matrix in this way. So if this is the result after a few multiplications or maybe a square or maybe a cube one, then it is called a nilpotent matrix. We will be discussing examples of all these in the later class. What is a singular matrix? Singular matrix is nothing but the det of A is 0. Okay, so det is nothing but for a 2 by 2 matrix it is a AD minus BC, and for rest of the matrix we will be doing the modulus and I will be explaining you how it is done. And what is an orthogonal matrix? Here comes the major topic in matrices. Simple with the orthogonal matrix. What is an orthogonal matrix? Is simple that A transpose is equal to A inverse. So this is what orthogonal matrix is, and here we will be discussing what is the inverse of the matrix and what are the eigenvalues and eigenvectors. Simple eigenvalues, or we can say that there are roots of this, and eigenvectors is nothing but a directional way of representation of the eigenvalues. We will be discussing about the rest of the things and we will be solving problems in the next class. Thank you.